Hi guys. So this series of Explaining Everythings is going to be surrounding the content to do with memory and the memory sack. Just to remind you, the sack is next Wednesday, it's going to be after school, and it's going to be at your home campus. The way the sack is structured is that it is going to be 3 scenarios, and within those scenarios there'll be 4 to 7 short answer questions, and the mark range will be from 2 to 5 marks. Now, all over, this is going to be worth 40 marks, and so you will have about 1 hour to do the task. That will include reading time. Again, remember, this makes up 25% of your Unit 3 coursework marks. So this SAC is a really good opportunity to maintain your score, your coursework score, if you are where you want to be, or it's also a really good opportunity for you to bump it up. Now, as you can see, this is divided into 3 sections. Because we've kind of been all over the place with the memory content, I thought that I would be a little bit more detailed in this series. So let's get started. Okay, just a bit of background stuff on the neuron. You're not going to be explicitly tested on the neuron, but it always helps to have an understanding of what's happening in terms of the structures and the functions of the neurons. Now remember, the key part of the neuron in terms of the neural basis of learning and memory is, of course, the synapse. Now the synapse consists of 3 parts. It consists of the axon terminal of the presynaptic neuron, which you can see here. The second part is the synaptic gap, which is obviously between the pre and the postsynaptic neuron, and then we have the dendritic spines of the postsynaptic neuron. So all of the changes for learning and memory occur within the synapse. Just a little bit more background information. So again, you will not be asked a question on the communication process between neurons because that was AOS 1. But again, it is helpful for you to understand what is going on in terms of our synapse. Now remember, when you're talking about the synapse, you should talk about the presynaptic neuron. You should also talk about the postsynaptic neuron. Now, it's not super vital that you do that, but it is good practice for the exam. So in terms of the communication, remember that we have 2 types of messages. Within the neuron, we have an electrical message, that is our action potential. Between the neuron, at the synaptic level, we have the neurotransmitters, which we know about, and they are chemical messages. So the neural information is received in the dendrites of the presynaptic neuron. So they're taken up by the receptor sites. That information travels via the soma or the cell body along the axon to the axon terminals in the form of an action potential. Now that action potential is electrical in nature. The axon terminals, they contain the synaptic knobs, which obviously have the sacs of neurotransmitters, and when the action potential reaches the axon terminals, they stimulate the secretion of neurotransmitters, and they travel across the synaptic gap, and then they bind or are taken up to the receptor sites on the dendrites of the postsynaptic neuron. Now, depending on the neurotransmitter, we can have an inhibitory effect, like we have with GABA, but we don't need to worry about that for memory, or we have an excitatory effect, like we have with glutamate. Now, as you know, that is certainly something that you need to know for this SAC. So let's look at how our neurons, more specifically how our synapses, change over time and across different situations. You may wonder what plasticity means in this context. What it means is our brains change, or that our synapses are malleable. We have different types of plasticity, which you learnt about in 1-2. So we have developmental. In utero, what that means is our brains will start to develop, and then after we're born, our brains continue to develop up to the age of 25. Now, that whole process consists of the cell bodies separating and multiplying. It consists of the connection between those cell bodies or neurons, And then in certain stages of our life, it consists of periods of pruning, when we get rid of old or weak or useless memories to make room for new and more useful ones. Now, well, that's one type of plasticity. The one that we're probably more interested in is adaptive plasticity. Now, adaptive plasticity kind of consists of two things. It consists of how our brains change as a response to learning. So every time you learn something new, your brain is going to change. And how we overcome damage. Now, in this context for memory, we're looking at how our brains are adapting to changes in our environment that actually let us learn. So, plasticity is like an umbrella term, I suppose, that consists of LTP and LTD and how those structural and functional changes kind of interact to allow us to unlearn information that's not necessary and learn new necessary information. So there are two types of plasticity. We have neuroplasticity, and that is how the brain changes in response to stimulation from the environment. Now, what we're talking about here is practice. Every time you engage in something, that's practice, or every time you remember something, every time you redo a skill, every time you do a question, that's practice. That's stimulation from the environment. That's experience. And that experience makes those changes in your brain. Now, as we spoke about in class, we have two different types of changes. We have things like LTP, which is the strengthening of existing synaptic connections and the creation of new ones. And we have LTD, and that is the weakening of synaptic connections and pruning. At a more specific level, we have synaptic plasticity, and that is how the synapses change over time as a result of this practice or this experience, or lack thereof, I suppose. So when we're talking about learning, you must remember that while we do have different parts of our brain that is plastic, like our cerebral cortex and that kind of stuff, learning and the mechanism of learning and memory is actually occurring at a synaptic level. So it's not about the brain, it's about the synapse. It's not about the neuron, it's about the synapse. One of the ways that our brain or our synapses can change as a result of experience or learning is long-term potentiation. Now, you need to make sure that you know this definition really well. So I want it to be word perfect. Go home and make sure you learn it really well. So long-term potentiation, this is the long-lasting strengthening, so strengthening is important, of synaptic connections. Remember, the strengthening is at the synaptic level, resulting in enhanced functioning of those neurons. So what does that actually mean? As I said before, every time you engage in some kind of experience, and in real life what that means is practice. So every time you do a question, every time you remember something, every single time you kick a football, every single time, what's happening is that you are stimulating that neural circuit. Now, every time you stimulate that particular circuit, what's actually occurring at a synaptic level is the strengthening of these connections. Now, the strengthening of those connections are these things down here, okay? So we can have the functional changes and the structural changes. So your synapses are changing because of this practice. And what that actually leads to is a more efficient or faster communication between neurons. So the transmission is faster. Now, in real life, what does that mean? What it means is that when you practice, you're much better at that task than before. So, for example, if you learn to kick a football and you've had, let's say, 5 weeks of intense practice, then you should be able to kick that football much better than when you first started to practice. It should be faster, it should be more efficient, it should be smoother, it should be something that you maybe don't necessarily think about as much. If we're talking about things like recalling information in a SAC situation, Consider how easily you recalled information from memory at the beginning of the revision period as compared to the end of the revision period. So at the beginning, it took you a really long time to recall certain information. At the end, hopefully, fingers crossed, you've had enough practice so that you can really easily recall that information. So essentially, because these things or these synapses are strengthening, we have these changes here. We have faster communication, that's why it's enhanced functioning, and in real life it means we've learnt a skill. The skill is faster, it's better, it's smoother, whatever. So in terms of the strengthening, what's actually happening? Remember, you must make sure that you know functional changes and structural changes. Just as an FYI, functional changes are an indication that we have made a short-term memory. So, when you make a short-term memory, we release extra neurotransmitters into the synaptic gap, and that's taken up by the postsynaptic neuron. Now, we know that that specific neurotransmitter is glutamate. So when you start to practice something lots and lots and lots, we have an increased level of glutamate. The other functional change you can talk about, but this is probably harder to remember, is that we have an increased sensitivity of the receptor sites on the postsynaptic neuron, which I think I've put somewhere down here. So that's actually functional. In terms of structural changes, I want you to make sure that you know at least 3. So we have an increased number of receptor sites on the postsynaptic neuron. And that's why, they tend to get more sensitive because we've got more, so they can take up more neurotransmitter. We have the growth of dendritic spines down here, so we get bushier dendrites, and you can say that. We also have growth of sprouts or filigree appendages, and together with the growth of the dendritic spines, they actually make more connections. So what's actually occurring is an increase or a growth of new synapses. So to recap, functional changes are an increase in neurotransmitter, which is glutamate, increased sensitivity to neurotransmitter on the postsynaptic neuron. In terms of structural changes, we have increased number of receptor sites in the postsynaptic neuron, we have bushier dendrites, we have increased filigree appendages and sprouts, and together what this means is we have an increased number of synapses. And remember, when we have more synapses or new synapses, that term is called synaptogenesis. So remember, synaptogenesis is literally just the growth of these new synapses, which links into long-term potentiation. The other way that our synapses change is through long-term depression. Now, long-term depression is another definition that I want you to know well, so I want you to be word perfect. So long-term depression is a long-lasting decrease in the strength of synaptic transmission. So what's happening is we are not practicing those tasks as much. We're not engaging in them. So we have less neurotransmitter, and so therefore the communication between the synapses or between the neurons is weaker. It's slower. So what does that look like in real life? What it looks like is forgetting. Structurally, what this means is that the postsynaptic neuron becomes less responsive, which means that we have slower communication. It also leads to pruning, okay? So we're shearing away those dendritic spines and those synapses. So I suppose the question is, why do we actually need long-term depression? There are a few reasons. We need long-term depression primarily to forget things that we don't need anymore. So we might forget something that we've learnt wrong. We forget information that's unnecessary. Or we might forget information that's traumatic for us. Now, what I would make sure I would do if I was you is I would look at long-term potentiation and long-term depression in terms of how they interact, okay? So let's say, for example, that you You've learnt a skill, you've learnt how to do a backflip, but your technique is all wrong. So how do LTP and LTD interact to allow you to relearn the skill properly? Well, long-term depression is when you have the long-lasting decrease in the strength of the synaptic transmission. So you are not practicing the wrong technique, and so what that results in is that particular skill, the incorrect technique, getting weaker or you forgetting it. Then, long-term potentiation is the long-lasting strengthening of synaptic connections, which leads to increased functioning or increased communication. Now, what this does is because you're practicing the new improved technique, it means that we have those structural changes with that new technique, and that new backflip or the new technique for the backflip is faster, it's more efficient. When you're talking about these kinds of questions, you need to make sure you're defining LTP and LTD and you talk about how they affect that skill. Do we forget? Do we learn? Is the message or the skill becoming less efficient and the neurons weakening? Is that skill becoming more efficient and the neurons strengthening? That's kind of what you have to consider when we're looking at questions like this. The next thing that we're going to look at is neurotransmitters and neurohormones. Now, I know that you're familiar with neurotransmitters. Neurohormones are a little bit different. You should make sure that you have an understanding of the similarities and the differences of neurotransmitters and neurohormones. I suppose, realistically and simply, they are both chemicals that are released by the presynaptic neuron. They both excite or inhibit a response, but the differences include this. Neurotransmitters are released directly into the synaptic gap. They carry information or messages from the pre to the postsynaptic neuron. And they only really have one function, and that's as a neurotransmitter. Because we're only going from the pre to the postsynaptic neuron, the effect is pretty quick. Neurohormones are a little bit different. So rather than going from the pre to the postsynaptic neuron in the brain, what we're actually doing is we're going from the brain down to a body part. So the message or the chemical is actually released into the bloodstream, and it goes from the brain, as I've kind of like shown you down here, to like the adrenal gland or other places. And that's actually going to affect specific organs. So things like adrenaline's going to increase your heart rate. It's going to make your pupils dilate. Now, the difference again between neurotransmitters and neurohormones is that neurohormones can function as a neurotransmitter or a hormone. Okay, so they can actually have an effect in the body or in the brain. We are going to look at the role of glutamate as our neurotransmitter for learning. Now, we know that glutamate is an exciter or a neurotransmitter, so it continues the message at the postsynaptic neuron. What it does is enhance information by making the postsynaptic neurons more likely to fire. In actuality, it actually has two roles. So it activates a postsynaptic neuron, so it continues the message. And when there is an increased level of glutamate, it produces long-lasting changes to the synapse. What we're talking about here is LTP, and we're talking about consolidation. And that's all you need to know about glutamate. Now that I've spoken about consolidation, now is probably the time and place for me to talk about it in terms of my slides. So consolidation occurs after long-term potentiation and synaptogenesis has taken place. Now we've made those changes at a synaptic level, the physical memory trace, the physical changes, and now those changes, those growths, need some time to set before we can say that they are relatively permanent long-term memories. Now, consolidation and the process of the setting of these neural circuits and of these synapses, it's like concrete. So, when we pour a slab of concrete, that change, that physical thing, I suppose, actually needs a period of time to set before it becomes relatively permanent. Now, if we look down here, we can see there's been some kind of disruption. Now, this has changed the physical nature of that concrete forever. This is kind of similar to consolidation. So consolidation is memory is being permanently stored through a process where there are physical changes to the neurons. Now, there are 3 conditions required for there to be successful consolidation. And if one of these 3 conditions aren't met, then you will not consolidate those particular memories, which obviously leads to memory loss. We have the physical change. So LTP and synaptogenesis must occur. We cannot have consolidation if there is no LTP and synaptogenesis. So we actually have to have a physical change to the synapse. We need a period of time for that physical change, like the concrete, to set. And theory suggests the minimum amount of time is 30 minutes. Now, within that 30 minutes, if there are no disruptions, then that's fine. Your memories will set relatively permanently in long-term memory. And they should be relatively resistant to any kind of disruption, unless you retrieve and reconsolidate. But what actually happens if there is a disruption? Well, that's our third condition. So let's say, for example, that you are driving home from the psychology class that we had today. And all of a sudden, you're in a car accident and you sustain a knock to the head and you briefly lose consciousness for a few minutes. Well, what's happening here is that there is an interruption to the consolidation process. So we've had an interruption. And so because we've had an interruption, that means that the memory trace, or those physical changes, do not form properly. So those bushy dendrites, those synapses, they're not forming properly because there's been this disruption. And what that means is that the memories that you made 30 minutes prior to the accident aren't actually forming properly and you lose them. So when we're talking about, knock to the heads and disruption, we're talking about the fact that there's an interruption. This means that the memory trace does not form properly, or the physical changes don't form properly, and therefore you lose the information 30 minutes prior to that disruption. So the last thing we're going to talk about for this particular part of the memory lecture is the role of adrenaline, which is our neurohormone. Now, remember, adrenaline is a hormone when it's released into the bloodstream from the adrenal glands. Now, that occurs when we are feeling stressed, okay? So it's released into the bloodstream, it travels the body, and it causes a number of those physiological changes that we talk about. So we've got things like an increase of heart rate. We might have increased concentration if we have optimal levels of adrenaline in our bloodstream. We might have dilated pupils. Now, when we have those optimal amounts of adrenaline, this is when we have an increase in the consolidation of emotional memories. When we have too much adrenaline, this can actually inhibit our memory formation. So how does it allow us to consolidate an emotional memory? So what happens is when we are having an emotionally significant event, the adrenaline activates the amygdala. And so the amygdala, remember, is responsible for the processing and the storage of emotional memories, particularly fear and aggression. So the amygdala signals to the hippocampus, and it says that the details of the experience, so the explicit memories, so like the events, the episodic events that are happening to you right now are significant, and that it should be stored really carefully, or those long-term storage, it should be strengthened. So that single significant event, which is emotional, it's going to be strong enough to cause those long-lasting memories. So that's why when we, remember something that was really intensely emotional, we tend to remember it really, really vividly, like flashbulb memories and things like that. So we do that, and that occurs to help us enhance our survival in the environment. So, for example, if I was bitten on the leg by a dog, and I was really, really scared, then I would remember that for the rest of my life, and maybe I would avoid dogs. Now, in terms of evolutionary psychology, what that should do is that should help to keep me safe in my environment. What we have to consider, though, is that it can be a hindrance, so it can lead to things like PTSD. So just remember, in terms of adrenaline, we're talking about heightened emotional arousal. And so adrenaline releases noradrenaline in the amygdala, which has a role in fear, and that activates the amygdala to signal to the hippocampus that the details of the experience, the explicit experience, is significant and it should be strengthened.